Friends, very good morning to everyone. In the last presentation, we dealt with the solution phase sequential strategy for the synthesis of oxytocin. In this presentation, let us deal with the solution phase convergent strategy for the synthesis of another peptide. Today's subjection of discussion is the synthesis of biphalin derivative. Biphalin is an tetrapeptide which is dimeric in nature. This was first synthesized by Lipkovsky 40 years ago. This is an N-cephalin analog, a dimeric analog of N-cephalin. N-cephalins, as we know, they are the natural ligands for opioid receptors, which has very good usage as analgesic agent. The tetra amino acid fragments present in the biphalin is phenylalanine, glycine, alanine, which is D isomer, and tyrosine. These are linked via hydrazide bridge. The hydrazide bridge is there. This on the two nitrogens, it is linked with phenylalanine followed by glycine followed by alanine followed by tyrosine on both the sides. This requires a solution phase method of synthesis. This has very good advantage as it has two distinct pharmacophores. Because of these two distinct pharmacophores, it confers higher affinity towards both micro and delta opioid receptors with the effective concentration 50 in the range of 1 into 5 nanomoles. This extraordinary in vivo potency that has been coupled with lower side effect, especially the dependency which is caused when you use morphine to as a drug. That's why biphenyl derivative synthesis has gained the popularity. Later on, other set of researchers they replaced this hydrazine group by piperazine and they got better activity and they reported its synthesis in arch form. Here you see they took bark protected phenylalanine and they activated the carboxylic acid by treating with dicyclohexyl carbonamide derivative and hydroxybenzotriazole in the presence of N-methyl morpholine as a base where these get activated into benzotriazole ester. This activated ester is treated with another piperazine in DMF and another acid and both will react at the NH in the piperazine to give diphenylalanine piperazine. In the second step, the bark is deprotected by treating with trifluoroacetic acid and DCM in the ratio of 1:1 and stirring at room temperature in an hour. Again, this is treated with the EDCHCl and HOBT, where the carboxy group of glycine has been activated, in which the bog it is the amino group is protected by bog to give rise to glycyl alanine piperazine in a form of dimer. Further, it is deprotected. The bog deprotection is done by using trifluoroacetic acid DCM, and again D-alanine, in which the amino group is protected by bog, was activated by treating with EDC and HOBT in the presence of N-methylmorpholin in DMF at room temperature and stirred for 24 hours. We get corresponding D-alanyl glycyl phenylalanine piperazine, a dimer. This is further Bach deprotection is carried out by trifluoroacetic acid, and Bach protected tyrosine was taken and its carboxylic acid is activated by treating with EDC and hydroxybenzotriazole in DMF at room temperature for 24 hours, where I will get the corresponding tyrosinyl derivative. The Bach protection is removed by TFA and DSM in 1:1 ratio to give rise to the Biphalin derivative. This has been reported in Arch Pharmaceutical Life Sciences in the year 2014 in volume number 347, page number 305 to 312. This is the segment strategy which has been followed for the synthesis of biphalin derivative in solution phase. The same methods have been used even in solid phase peptide synthesis. Convergent synthesis using solid phase peptide synthesis, one of the molecule was reported in molecules in the year 2020, which has been mentioned here. A convergent synthesis by using solid phase peptide synthesis, where the insulin has two chains with 21 and 30 amino acid residues. It has been reported by Journal of American Chemical Society in the year 2013, where they prepared three chains, 2, 3 and 4. 2 and 3 are first ligated, and this ligated one has been ligated with 4 to give the corresponding insulin, which folds in the similar fashion as that of the natural insulin, in which there is sulfur-sulfur bonding is formed by using a ligation strategy. This is convergent method of synthesis of insulin by SPPS method. This is all for today's presentation, and each of the syntheses, either by solid phase or by solution phase, the side chains present in the amino acids has functional group, and they have, because of that, the side reactions. What are the types of side reactions that occur in the peptide synthesis and how it can be prevented will be the subject of discussion for the coming presentation. Till then, have a nice day. Thank you.